Welcome to the Semantic Web and Open Data session. We'll be talking about opening up data and its links to the semantic web. I've been doing this for about 2 years or so. To me, the links between open data and the semantic web are quite obvious because linking up data only happens when you have data to link together. So I'm just going to hand over to Nigel. I don't think he needs much of an introduction. If anybody hasn't heard of him, you will know him by the end anyway. So, Professor Shadbolt, would you like to come and talk to us?
Okay. Well, so I'm just going to set a bit of context and actually talk about linked data, which is the kind of early kind of ancestor for more of the elaborate semantic web discourse you hear about. I believe I'm still a government advisor on information. I mean, who knows? But the things have certainly changed. The interesting thing is that in this area of opening up data, there is an really quite interesting political bidding war that certainly went on before the election. And if you read the Conservative manifesto, there's much talk of transparency, of releasing some really quite sensitive data, transactional financial data. I'll be talking quite a lot more about that and where the politics of this are likely to go in the keynote I'm giving later on this afternoon. So let me just say something. Sometimes you're just lucky, and all I would say about where we are with what we're trying to promote in terms of open and linked data is you can just sometimes catch the wave. Tim Berners-Lee and I were asked by the government to help put public sector non-personal information online back in June. We had a very simple, very naive approach. We'd use open source software, beta release, build a community from the bottom up, and just go and bang on people's doors really, and use whatever means, fair or foul, we could to get the data out. But at the same time that was happening, there was clearly not just a kind of a competition of ideas between different political parties and a convergence in some areas that this was a common good, but countries were doing it, cities were doing it, organizations and even individuals all releasing data. You wouldn't think public sector data would set your heart racing because what's it about? It's about schools and roads and emission levels, but actually what I can see from the community is it does. It's really exciting. This is a fantastic journey, and it's particularly fantastic when you get things like mapping data out there freely available. And the US, of course, and Vancouver and London, people thinking about this whole thing. Why? Well, of course, don't rehearse these, but it's transparency, accountability is used, improving public services because you can more easily look at the data and think, well, this isn't as good as that, why not? You could be your own kind of arbiters of comparison. Clearly generates some economic value, we're seeing that already. I've got this lovely iPad application of all of the raster ordnance survey data that I can zoom in and out of, and I'll pay $4.99 for that. $4.99. And it's freely available, but I'll pay for that app because it's just well packaged, well produced. Societal value in terms of all of the goodness that flows from people being able to more effectively engage with their public services too. And as Chris Taggart and others have been talking about today, this allows the citizen to engage, not really engage, to both generate, give and provide data to improve and critique the existing issues there. So this is all background we can probably quite well familiar with, and again I'll amplify these points in my plenary talk. Why linked data? Okay, so the really interesting thing about what we've done in the government work, Tim and I have got the government to adopt what are called public data principles. There are 7 of them in the white paper on smarter government, and they start with injunctions that your data, if you release it, will be machine readable. It will be machine readable. So the notion that releasing it as a PDF or some other completely derelict format is not sufficient to have met the standard. And that you will use open standards. Now, what I'll be talking about, of course, is a linked data standard, is the RDF formulation of that. What I would say about linked data is this is not a semantic free zone. Absolutely not, okay? And the only unfortunate thing about the term linked data is it uses the data term. It's not data, it's information. It has an implied or an explicit, very often, semantics. You know that this number is a population statistic. Okay? You know that it was collected in a certain context in a certain time. The other thing that is characteristic of the linked data approach is what we might think of as lightweight ontologies. That is not one monolithic integrated public sector vocabulary, which was originally designed to classify documents, not really much used to characterizing data, but lots and lots of ontologies emerging to describe education and transport or environment. And you're able to mix your vocabularies. Crucially, in both the semantic web and linked data approach, you can query into the data sets using a prefix which tells you to go here for this vocabulary, here for that vocabulary, and mix them together. And there are only 4 principles in linked data, and that's right, because the first web worked by having a very thin set of micro principles that sat across the original internet and scaled. And there they are, URIs, in other words, web addresses for data, that you type them into a browser and you get something back, and that you use a particular format. I'm sure we'll have arguments around that, and that you should link these components together. And when you start to consume and produce your data in this way, you start to live in a world that becomes very exciting. But it is not a semantic free zone, because you have to describe the ontologies, you have to describe the vocabularies, you have to assert principles to link it, such as this URI and this URI and this URI are the same thing. Now, it will be rough and approximate in lots of ways. That's another interesting feature. This web is somewhat scruffy. But what we learned powerfully, those of us who came out of a background in artificial intelligence, was that logical consistency cannot be enforced at planetary scale. It just, not that anybody really thought it, well, perhaps some people did, but that really what you're looking for here is local islands of coherent data that you link together at particularly interesting join points. So I would say that the linked data is a pragmatic semantic web. Don't set the one against the other, it's a false opposition. What we as researchers in academia, and I will declare myself as guilty as anyone else, often won't do is spend 80% of our effort designing features into the system that are jolly interesting from a full-blown semantic point of view, but of little interest to most of the population out there consuming this stuff. So in a paper that Tim Berners-Lee and I and Wendy Hall wrote called The Semantic Web Revisited, we went through these basic principles. And to give you a sense of how that's worked, let me do the ultimately dangerous thing and fail to get my browser window up. Okay, that's clever, isn't it? Oh, I'll restore it. What I'm going to look at here is some data that is being linked together using those very simple principles I talked about, plus some other very simple services. And I do have a web connection here, do I? Perhaps not. Oh, is it? Oh, then it's entirely my mistake, and I will not be able to show you the... Should it be? Okay, let me get rid of a lot of this guff. That can go. Okay, here it is. Okay, it's fine. Got it. Okay. So this is a website, map.psi.enacting.org. Don't all hit it just now. But what we have here is essentially a set of services. Oh dear. A set of services that bring together linked data resources and importantly provide services that allow you to, one of the classic things is, if I have this data set from transport or a data set on carbon dioxide emissions, what does it refer to? Some of the key identifiers, the URIs in there, will link into other elements. For example, the particular administrative geography in which the emission was detected. So which bit of the country's geocoding does it relate to? Or which bit of an identifier in openly local does it refer to? The wards that are identified in openly local. Or what bit of DPpedia? And this is very slow. to the point at which it's not usable. So, and that may be because I'm running a WebEx session in the background. So let's switch that off. Okay. And the provision of these services on top of this lightweight semantics makes for a very interesting capability. So let us see if this does any better by starting up. Perhaps not. I should have canned it and recorded it. This will teach me for future reference. The point I will want to make with the approach here, and I get it, is that with a little semantics, with a little organized vocabulary, with some services that connect the join points. And here, one of the key notions is there is what we call totemic data. There are particular parts of our national data sets that really tie the rest together. One of the reasons that Tim and I went into bat so hard to get Ordnance Survey data was that you can't make sense of a lot of the other data unless you know the administrative geography of the country, unless you know something about the actual inclusion relationships between a ward and Hampshire and a unitary authority and something else. If we are going to bring to bear unlocking data as a linked resource, we have got to have at least the semantics of geographic containment, of temporal inclusion. These are the places where we can find real value. So we're building a digital national infrastructure in the open data community that's semantically relevant too. When we build web addresses for our schools and roads and bus stops and postcodes, they have never existed before. Okay. Designing them right, designing them for change, to survive in the face of change management. Well, they've existed before in some sense, but in local, very, very local silos. And so the notion of adopting the open standards is that now a URI for a school, a URI for a postcode transcends, escapes from these proprietorial formats. We think that we're beginning to see already that as people use these data sets and link them together, there'll be very interesting long tail effects. Just as if you go to the linked data cloud at the moment, you see DPpedia heavily featured, the Wikipedia version of the linked data, as heavily referenced, or geo names. There will be particular bits of the digital real estate that we rely on hugely. So I think that we're going to see huge development in this area. And just to wrap up, the kind of advantages we're seeing now is if not just nations, but an individual nation or individual city adopt these open standards. But if we do it collectively, you can begin to do some really interesting comparative work. So this is work on comparing, using linked data formats, foreign aid giving in the US and the UK. Okay. And this was built actually by Jim Hendler's group in the US, using our open data here in the UK. Or, more contentiously, comparing crime statistics in zip codes and postcodes. Now there you get into more interesting comparative challenges, because the semantics of this term under larceny and burglary, larceny in the US and burglary, and the conditions under which it's a fair comparison become very important. Okay, and so the semantics don't go out the window here, and we're seeing, of course, with the adoption of these linked data standards, the ability to tap into this emerging cloud of wider linked data. And this representation from just a few months ago does have very little representation of the open government data that's now available. So, why now? We're building it fast, we're building it in an activist fashion, we've got an engaged and enthused developer community, there's a lot more to do. And when people say, well, why you shouldn't do this, and we've heard some of these worries, lost revenue, the mosaic effect, the fact that putting all this stuff together actually begins to reveal things unintentionally about people and places you might worry about. We have, I think we're obliged to finish this up, to show real value that's directly relevant to citizens, in the same way that the example this morning about the medical records being made available to individuals, or Chris Taggart's slides were very insightful, I think, in this regard as well. So it excites me, and I better shut up and give the floor, I think, now to Peter. Okay. Thank you.
Thanks for that. The room's kind of filling up now, which is great. I'm going to try to keep all the questions to the end because we'll have a panel discussion afterwards. Yeah, don't feel that you won't get your say, or if you have any questions, make sure to ask, but try to keep it to the end. Just about ready? Yeah. Excellent. So I'm going to hand over to Peter Crowther. His notes say that he's been on the internet for 25 years. So it was kind of hard to get him in today because we had to download him. So I'm going to hand over to Peter. Thank you very much.
I'd always recommend applauding afterwards rather than... I've got perhaps a fairly practical or pragmatic view of where I want to take my talk. And it is around pretending, if you will, that I am the Director of Informatics at an NHS trust. And they're looking at this weird open data stuff, and they're wondering what on earth to do about it, how on earth they can make use of this. So what does it mean is not just around the semantics. There's quite a lot of head scratching going on as to how on earth we use this at all in the first place. So as to protect all of the NHS trusts I've worked with over the years, I'm going to use the mythical example of the Ancoats General Hospital. Those of you who have seen the building will know that we do need a little bit of budget for repairs, but we do believe that fresh air is good for our patients. Probably a good thing given that lot. You can see more details on our website, which is www.ancoats.nhs.uk. We've had that for years. Now, like other hospitals, we've got to provide statutory reports into the Department of Health. Those reports could be retrieved by a Freedom of Information request. And we've got a progressive chief executive, always on the lookout for something that will differentiate the trust from anything else and hopefully propel her up to even greater stardom. So she's asked us to investigate the idea of making all of the statutory reports, anything that you could get through an FOI request, available as open data. So we looked at that, and we looked at really four problems. How on earth do we describe the data's origin in the first place and how it's been processed? How do we define what the terms mean in each of the reports and other bits of data that we want to put online? Once we've converted this stuff, how do we make it available to the consumers, whoever wants to consume it? And how do we be good open data and linked data citizens? How do we help our data consumers to use data from many different sources? So, first step, data cleansing. Not, as some might consider, hard drive scrubbing, though that's what you have to do with patient data at the end of its life. I know one organisation that takes hard drives and literally drills holes through them and then fills them with packing before disposing of them, just to make sure nobody else gets to read them. Anyway, one of the nice things about being in hospitals and in the medical world is that codes have been used for a very long time. There's the READ clinical classification, now the NHS clinical classification. There's SNOMED, there's ICD codes. It's the usual wonderful thing about standards. There's just so many to choose from. In our case, for data cleansing, what we've got initially is a big stack of date, patient, where it came from, because we've got data from the trust, but we've also got data from GPs as well. In this case, a READ code, which are 5-character magic codes, a rubric about what that code should be, and potentially a value. And any of you who are involved in any kind of data manipulation, data munging I've seen used in many places, will be well aware of what happens next. You take this big stack of 100 million or so rows of data, and you throw quite a lot of it away. You end up removing data that the format just doesn't match. You have to add values from unexpected places. For example, the code for blood pressure, wouldn't it have been nice if this person had actually entered the blood pressure in the value field? Wouldn't it have been even nicer if they'd not only entered it in the blood pressure value field, but they'd also entered 2 rows, one for the systolic blood pressure, the pumping pressure, and one for the diastolic blood pressure. So we've got all of that kind of correction to do, as you have to do with medical data anyway. We've got to scale values. Hemoglobin A1C measured as a percentage. What's 5.3 then? Is it actually 0.053, a fraction of what's out there? And sometimes you just have statements. Urea and electrolytes, normal. So we end up doing things like scaling values. Once we've done that, we've got things like extra rows in the table and collapse a few synonyms just to bring everything back. Okay, so we've now got some clean data. It's the kind of thing that we could put in the Trust data warehouse and be really proud of ourselves. Now what? Somehow, we have to get that out to the wider world. And the Humpty Dumpty quote on this front is unfortunately entirely opposite to a lot of the semantic web effort. When I use a word, it means just what I choose it to mean, neither more nor less. And that is unfortunately true of URIs as well. A freshly minted URI with no description has arguably no meaning. Certainly no meaning that a machine could deduce. There's certain principles you can apply to it. There's a prefix there, so it might be controlled by that organisation. There might even be something human readable at the end, but you can't really guarantee it. So how do we start to look at our terms? How do we start to look at exposing what our data format is to other people? Well, the first rule, don't reinvent the wheel, or in this case, don't reinvent the URL. Link to other people's URLs for terms wherever that's possible. If somebody else has already done it, why on earth should we? But there's almost certainly going to be cases where we're going to have to magic identifiers out of thin air. There's a reasonable chance that not all of our staff, for example, have already been listed by somebody else. So we need to create URLs for terms, but only where necessary. We'll encode values. In fact, we'll encode the whole thing using RDF XML. We will be good web citizens, semantic web citizens. We need to think about things like how on earth we model not just measurements, but units of measurements. Millimoles per litre, how on earth do I define that? Cubic meters per minute, where do I get that from? And when I start representing the data, do I attach one of these units to each data point? Do I somehow attach them to a definition of the type of data? What on earth do we do about telling people how our data is going to be modelled? There's a number, again, of standards in this area. The ancestor of all of them is probably RDF schema. And then you've got things like the Web Ontology Language, OWL. A long time ago I was on the standards committee for that. You've got, starting around the same time but being standardised rather later, the Simple Knowledge Organisation System, SCOS. So we're sat here in a hospital trust with a fairly limited staff and fairly limited time. What do we choose? So our trust sent one of the staff away to try and make this decision. And they looked at RDF schema and reckoned it probably wouldn't do the job. And they looked at OWL for a week and asked for some headache tablets and realised that actually, no, they weren't going to be able to get their heads around this. So let's use the one that seems to be fairly popular out there at the moment, SCOS, the Simple Knowledge Organisation System. We'll see whether it works. And something that I was hoping Carol would talk about, I suspect she's not going to in this case, how on earth do you version schema and how on earth do you version
I'm going
data?
to phrase it as a worry.
Oddly enough, so am I. How does this lot change over time? Okay? So there's all sorts of things to worry about. In the end, we'll take our data, a miracle happens, we'll expose it as RDF XML using the simplest possible approach, and we'll model our hierarchies using SCOS. Okay, let's try that. Right, once we've created the data, how on earth do we get it to our potential consumers? The hardware and the network are generally the least of our worries at this point. Almost always, the problem is not how on earth you publish the data, it's getting the permission in the first place, getting it out of the corporate or particularly the NHS data vault. So in terms of making it available, the technical side, we'll probably need to install some new software. Might even be from Thales. We'll need to provide some way of getting into this via something like a query language. Let's use Sparkle, everybody else seems to be. And let's provide some tutorial and canned queries for our standard reports so that at least people have a way into our data. But hang on a minute, the Trust's got something called a Caldecott Guardian. This is the one that has to protect against the release of personal data and patient data. Any data that comes out of the Trust has to be got past them. So we've got legal implications of releasing data. And it's not always the ones you think it is. For example, with one hospital trust and primary care trust I worked with, the primary care trust realised that they had a data sharing agreement with all of the GPs for particular purposes, and releasing the data as open data wasn't one of them. So you actually had to go back and renegotiate with the GPs a new contract to release that data. You've got the legal implications of releasing personal data. Now, patient data is obviously pretty clear, but an interesting one came up on the OpenGov developers list a couple of months back. A lot of GPs still operate single-handed practices, even in these post-shipment days. So anything about them counts as personal data. Even the very well published name and address of their commercial premises counts as personal data. So you have all sorts of unexpected legal hurdles to get over. There's also what I suspect is an unsolved problem. I've certainly not come across a solution. How do you defend personal data over time? Even if you're just releasing summaries and aggregates of data, this is going to be stored. The Wayback Machine is out there, just looking for data to keep. 10 years down the line, can somebody take 10 years of your reports and deduce when somebody's birthday is? Because they can see that somebody with a rare condition has moved across an age band in one of your summary reports. Or they can deduce where somebody lives very, very closely because the boundary has shifted just a few yards and somebody's moved between geographic locations. So there's all sorts of attacks that you can make on this data. Maybe not today, but Google will still be there in 15 years. And they want that data. So finally, how on earth do we make our data available to users? Those consumers of data may not necessarily have entirely the appropriate tools to do the job, but nevertheless, they still want to mix up our data with other people's and get something. In this case, I think it's pancakes. I hope it's pancakes. So how do we get data from many sources? How do we allow our consumers to consume that effectively? Well, first off, wouldn't it be nice to supply multiple data formats? If our software platform was flexible enough that we didn't just supply everything in RDF XML, We could give them the canned queries as comma-separated values if they really, really wanted just to use a parser to get the values out. Supporting web standards, the whole thing being dereferenceable. Nigel's already spoken about that. Being on the OWL Standards Committee, as I was, I will put a dig in about having some kind of machine processable schema as opposed to merely a machine readable schema. So our trust has worked out how it's going to deal with its data initially. New software, new machine, clean it, put it out as RDF XML. Let's look 5 years into the future. Richard Branson has just been confirmed as the new Prime Minister of a government of national unity to solve the UK's debt crisis. Manchester United has gone bankrupt.
Well, that's going to be next year.
Well, okay, I'm picking 5 years. And Greek citizens who were bailed out by the Eurozone 5 years ago are subsidising soup kitchens on the streets of Manchester. What worked, what didn't? Well, first off, we've merged. We're no longer just the Anne Coates General Hospital. We've just merged with the Nichols Hospital. Please go and have a look at our new website. Okay, it's at nicotes.nhs.uk. I've managed to hang on to my job as the head of informatics at the merged trust, principally because of this innovative new approach of setting up open data and linked data. Hundreds of other organisations are using our data. Our weblogs are telling us that. Lots of other URLs are, lots of other organisations are using the URLs that we've minted as well. It's all working really rather well. So our chief exec has just opened our new website at the new URL. We've got a few snags with that, because while we thought we'd picked a cool URL for our data, we didn't. Okay? Linked data is fragile. So some of the problems with all of this and some of the benefits. First off, if you think back to the Industrial Revolution, factory production, mass production of data meant very cheap data for consumers. Okay, sorry, of goods meant cheap goods for consumers. Bring that forwards to now, the semantic revolution, if you will, if it happens, means that we've got very much industrial data production. We're putting the effort in to make cheap data for users. Second off, we've found that collaboration multiplies the value of data. As publishers, we can get value from other people's use of the data that we put up. And that's great in a time of the last 5 years of cuts, where we've been able to rely on people scratching their own itch and then get some really nice results back that we never knew about beforehand. We found out that open data may require legal changes, contractual changes. We found out that linked data is fragile. Organisations change, and our URL change is going to cause us some problems. We found out that at least triples and RDF are more resilient to things like report format changes than CSV. And the one other thing we've found out repeatedly by people emailing us, phoning us, banging on our doors, is that some people just want CSV and a manual. We're about here on the semantic revolution, if you wish. I was hoping to get an image of a bike with stabilisers, but that one was far more colourful, so I'll settle for that. The idea that you've got a initial cut at the approach, and then you refine and refine and refine over time. There's one other thing that I predict medical organisations in particular will find, and that is that the simple knowledge organisation system is a little too limited for their needs. and they're going to have to go to something more complex, like the full web ontology language. I think Carol and I could have quite an energetic debate over whether any non-medical institutions would be doing the same thing. In fact, we were doing so by email yesterday evening. But at least the medical world will find that they are going to have to deal with the headache pills, spend the time learning the more complex web ontology languages in order to get the kind of benefits out of that they're going to need. I'll be happy to talk about that in the panel if anybody wants me to, but other than that, I think I'd better get out of the way, avoid the bored faces, and let Carol take over. Thank you.
Excellent. My position at the moment is really just hand over to Carol, so I don't want to take any more time than that. Snuck around behind me. So, everybody okay? Everybody sleepy? Excellent. Okay, we'll hand over to Carol.
Okay, so I'm Carol Goble from the University of Manchester, and I've been at the Semantic Web community for a very long time. I was right at the beginning of the efforts to do the standardization activity in Semantic Web, but I chiefly work with scientists. So my interest is enabling scientific data to get out and be usable and open, and to enable scientists to be able to collaborate and do some interesting, useful science rather than fighting their data sets and fighting access to those data sets. So I build social collaboration environments, including my experiment. I've got my stickers here, if you want a sticker for your laptop. I won't dare put one on here at the moment. So what I'm interested in is scientific data. Now, why is that useful to open data, government data, and so on? The web was originally piloted in a scientific incubator. It was developed by a physicist for physicists. And a lot of the difficulties of the web, and a lot of the interesting discoveries around how to use the web were pioneered by the scientific community, because the scientific community are typically early adopters, because they're very motivated to deal with mass collaboration and mass data sharing. That's what they do. And so we can already see that there was a future presented by Peter. The future is now. The future is yesterday from the scientific point of view. We've already done it. So what did we learn from those experiences? So in biology, which is the area that I particularly build systems for, what we're doing is orchestrating and interlinking large-scale data sets in various different kinds of heterogeneous formats, provided by multiple suppliers, consumed by multiple consumers, where those suppliers and consumers are decoupled. They don't know one another. And we also do mass collaboration. So science is done by scientists speaking to one another, collaborating and sharing, or failing to share. We're also in an environment where sitting on top of your scientific data set is a way of protecting your unique selling proposition, which is international fame and glory if you're a scientist, because it certainly isn't money. So this is very similar to the discussions that we had in the earlier data session this morning about why do people share and why people don't share. And the incentive models for sharing among scientists are the same as the incentive models that we have to build for people being able to share their data in government. What do I get what do I get out of it? Do I get credit? Do I get reputation? And do I get blame if it goes wrong? And what will it cost me if I do it? And will I be open to misinterpretation and scrutiny if I release my data and I release my data too early? So these are things I'm going to explore a little bit. And there's extremely, I'm sure all of you, who reads Nature regularly? Hey, some of us. There's a really good article about this in Nature, about why people don't share. Despite that, people are still sharing. And in fact, there's a move in science to do radical sharing. This is social tools for the social process of sharing the papers that I use, sharing the knowledge that I revealed, collaboration with notebooks, plugging my lab instruments directly into the web. People are doing this. And there's a whole move to do with open data, services, journals, software, all being radically shared. So I can't remember which slide, I left this slide off. So I've just come back from something called Sage Bionetworks. Sage Bionetworks is a not-for-profit that's rolled out of Merck pharmaceutical company. And what Sage Bionetworks is doing is creating a data commons of freely available bionetwork data. This is the data that you generate when you want to see protein-protein interactions or the causal relationship between genes, to make it free, to make it openly available. And there were 220 handpicked people at this meeting, including representatives of the White House, saying, yes, we will do this. Second thing, I'm on a big European proposal at the moment that is going to build, it's in negotiation, a shared linked space of semantic web data for the pharmaceutical industry in Europe. 8 pharmaceutical companies have agreed that they're going to take a semantic web solution to pool chemistry and pharmacological biodata so that they can do open innovation over a shared data commons for drug discovery. And the fact it was semantic web was irrelevant to both of those groups, because they're interested in the science and the technology. Well, yeah, we know about the technology. Now, I think that's an important thing. That's saying, my God, there's a shift. And the shift is because though these companies, drug companies, biotechs, can no longer do business in silos. They can only do it if they share. So they've got a prima facie driver. And it also, the other drive is that scientists, there's a new generation of scientists. The new generation, the under 25-year-olds who actually do all the work of science, the rest of their professors are on planes, doing talks, right? But the ones who are actually doing science are digital natives, always online. They're the catalyst for change, and they're used to radical sharing. So what we were interested in, what we're trying to do with the semantic web in the scientific community, is liberate data from the proprietary databases. Spreadsheets, liberating data from spreadsheets is the key thing for scientists. Standards for publishing and sharing and querying, that structured knowledge drawn from these diverse open sources, because it's the links between things that actually interest scientists. It's the relationship between this protein and that protein. It's the link that makes the difference. Science is all about links and mappings. Answer cross-source questions, because building links between data disciplines, being able to combine social science data, medical data, and genomic data in order to be able to answer basic questions to do with the phenotypical characteristics of disease, fundamental. Okay, so it's cross-disciplinary. And to pool those results, to put things back into the semantic web, not just to publish, but to repool into the semantic web, and to preferably repool natively, so that we put things back in as triples, as semantic web publications. In fact, there's something called the Concept Web Alliance, which is run by a Dutch consortium, that says we should just completely abandon publications, and instead we should publish knowledge, and we should cite knowledge, not triples, in our publications. And this is being taken quite seriously. In fact, one of the guys who runs that is one of the co-leaders of this new pharmacological triple environment that I mentioned earlier. The reason I talk about this science point of view is if you look at the linked open data cloud that Nigel pointed there, this piece here, which is a third of the cloud, is all science, it's all biology. It's actually called Bio2RDF. It's taking a large number of biological data sets and that are publicly available and turning them into linked data. And here's a client for it, which is just a native one, and it's not very pretty, but it's jolly useful because it's combining something like 45 different data sets and showing the cross links between them so that you can now build associations between things that were not there before. This is another client that's built by BioGPS, another kind of system, but it's using the same environment. It's using the fact that we've marshaled together a way of linking our resources to build a more sexy and sophisticated environment, but it's still based on this underlying framework. Here's an even much prettier and sexier thing called Utopia. is there's a document environment that says this paper, which is a PDF, is actually live. You take the PDF, you rip the PDF to pieces, it becomes an interactive document which is a view upon the linked data cloud. So when you click on this picture, it's actually a live picture. Although it looks like a paper, it becomes live, and now you can link from it. So this is a very interesting way of being able to step, so you don't frighten your scientists too early. They're used to papers, so present things through papers. But it's really live data. The paper is now a window upon data, rather than a tomb for describing data. Rather than trapping data in it, it becomes just the view upon the linked data set. And here's an even sexier version, which is the BBC Wildlife Finder, which is marshalling other scientific data sets with social data sets. It's not just data, there's a whole movement to do with describing scientists and their relationships to one another and their interests, and scientific discourse using semantic web technologies. So VivoWeb, which is a $12 million investment by the National Institute of Health, I think is, or is it NSF, whatever, one of those, stimulative package, is an environment for being able to describe scientists, what they're working on, how they work together. It's semantic web through the stack. Everything's described and available as semantic web, RDF, annotated with ontologies. And the same as scientific discourse. The Alzheimer's Forum, the Parkinson's disease online forums, these are all semantic web driven applications. And nobody cares, because when you look at them, it's just stuff, it's just a system, and semantic web is just routine. So why did these systems adopt this approach? Agility. The important thing here is we were able to do a rapid production. Because there was this unification of data, we were able to build other applications on top of it that required this unified data vision. It's avoiding reinvention, it's promoting information flow, and therefore accelerating the turns of knowledge that we can get in science from hypothesis to result and back to hypothesis by improving information flow, by sharing. And personalization is the other thing that you can get. I can design, I can do my own mashup, I can do my own query, and I don't have to wait for the IT guys to build me an interface. I can build upon that framework that's already in place. That's the good news. Here's the experience news. So the experience news is that if you think of the semantic web as this stack, there's this get your URIs in order, which is what Nigel said. Get your RDF in order, which is what Nigel said, as well as Peter, I have to say. And then you've got some syntactic normalization, and then you can build a linked data environment. And then there's the semantic normalization, which is let's have linked knowledge of lots of control vocabularies so that we can annotate the items, the URIs, with meaning. And we are definitely in this world. So all of that all those ideas are very much in the let's just marshal and link together data, with a view that later we can step up to this environment. The second thing is that we're aware of the fact that, as again Nigel and Peter pointed out, that there are these notions of entities and ontologies, your identifiers, identities, your identifiers, and your control vocabulary terms. But who manages those? It's a third piece. It's no longer just providers and consumers, but there has to be some sort of third-party business in managing this semantic infrastructure, managing the identifiers, managing the namespaces, managing the control vocabularies. Who does that? And the second thing I wanted to point out in this diagram is that these suppliers and consumers are decoupled, and that's important. That they don't know one another. They're not in a contract with one another. So that leads to serious issues, which I'll briefly mention in a minute. The important thing here is ramps, and I actually did this picture and then saw Pete's picture afterwards. So we are here, we're in the child with the stabilisers actually. I've got a picture with stabilisers on it. The middle-aged man on the bicycle is where we will have some simple ontological framework like SCOS or OWL to be able to annotate and control the values, what do the URIs really mean. But this kind of, real kick-ass, Olympic level cycling, I don't see that being other than in incredible niche applications. And so a little bit of structured data and semantics really goes a long way. But the important thing is these are access ramps. You can start with some URIs and link some stuff together, and then you can do something more sophisticated. In the semantic web, we went, at the beginning, we were a bit too much. Everybody was going to be an Olympic cyclist before we'd even found out where the stabilisers were. The other thing I found when I was putting this talk together, getting real examples of open data and the semantic web. I found lots of examples of enterprise level. So the BBC, for example, making all of their data available across the organisation, across the corporation, and dealing with their internal silos by publishing their data in a standard way. But finding convincing examples outside of the scientific domain was quite tricky. So where are the examples? We've got to build some examples. And where is the infrastructure? So where do you find semantic web? How do you know that there's a source of RDF data for a particular problem? Identity. Everything's predicated on things being able to be linked up. So Nigel mentioned the notion of same as. So you can say this identity is the same as that identity. Who does that? Who manages that same as infrastructure? And what if they're not the same as? Does it matter? It doesn't matter if you say I'm the same as, my sister. No disaster will occur. But it might occur if my sister turns out to be a terrorist. So that does matter. So what same as is dangerous. Okay. So that's a worry. Aggregation, there is no fundamental infrastructure for being able to group things sensibly. There is no fundamental infrastructure for being able to version things sensibly. There is no infrastructure for being able to build provenance. Where did things come from? There's no sensible infrastructure for context. And there's also issues to do with scalability and reliability. And that's because I will contend that the semantic web world's been too fixated on language specification and not enough on infrastructure specifications and infrastructure services that we need in the community. And the emphasis has been on lower barriers to publishing and not on lowering barriers for use. Where's my pipes? For semantic. Where's my semantic Drupal? Where's my semantic Apache? Where's my semantic pipes? I know those things are being developed, but they're all in research labs. They're not in the field very much. So provenance is absolutely crucial, and the World Wide Web does have an incubator to deal with provenance. But without provenance, I think there are serious concerns when we release lots of data into the open data cloud. And that's because with provenance, if we're using data and we've semantically enriched it, and we're semantically combining it, and we're aggregating it, and we're repooling it, we have to understand that data. It's too easy to aggregate. It becomes too easy to combine. It becomes easy to misinterpret. And there are serious dangers if we don't understand and respect the data as it comes to the sort of things that Peter was talking about. And I've got some interesting examples. I seriously recommend everybody sees Dana Boyd's World Wide Web 2010 talk, which is on the web. It's a brilliant description of what happens when good scientists, or good social scientists in this case, go bad misinterpreting information and data that's publicly available. Not because they're cruel or mean, because they don't understand what the data really meant and where it really came from. So my final slide is to point out that this is the kind of classical cake picture that evolves about all the technologies for the semantic web. But this is kind of also betrays, this grasping and hanging on to this cake picture, kind of betrays the fact that the semantic web has until now, until recently, been largely about technological determinism. We'll build the technologies and then it'll all be, we'll be fine. We'll have built the semantic web. And kind of miss the social cultural shaping aspects that I think Nigel in particular was referring to. And you can see that he kind of gives it away, because at the top is this word called trust. How do I trust what's there? What's the least emphasis has been done until recently on the trust bit. So we've got endless stuff about bloody URIs and Sparkle optimization and OWL and God knows what else, and hardly anything on trust. But in the end, that bit has to be there before you can really do open data. Thanks.
Carol seems to have taught everybody in the semantic web, I think. And if she hasn't, Nigel has. And then also, really quickly, I represent Talus. We're a semantic web company, and by strange coincidence, and actually not by design, tomorrow we're running an open day on working with data, with linked data. So if we've got 10 spaces available, we're putting on lunch, we're at the Manchester University Visitor Centre. So if you want to come along, learn about Sparkle, providing Sparkle endpoints for your projects, working with linked data, minting URIs, all that kind of stuff, have some hands-on demonstrations, and also talk of linked data in action, giving lots of demos of linked data actually being used, some of which using some of data.gov.uk's publicly accessible data sets as well. So get your hands on data and start building some cool stuff. That's why I do my job. So if we can start having a few questions. I'm going to ask you to use this microphone just so we can hear them all. Thank you.
My name is Igor Goldkind. I'm from Oxford Semantics. And Kara, I wanted to thank you for your talk, because I thought that you basically summarized the problems we've got, certainly in terms of introducing these notions to the private sector. And thank you very much. That was great. So what's the solution?
There were a lot of problems there. The trust problem. So there are some fundamental services and infrastructure that we need to put in place that becomes part of the web, just like HTTP is part of the web. So we need to be able to, particularly, I think the first thing, absolutely, is we need a prime mechanism that is universal for recording the notion of provenance. Where do things come from? And that means, I know that Nigel mentioned this earlier, that there were, he mentioned ontologies that described, or this is how I collected this data, but that's an ontology that's been invented by one group or another group, and each one has their own. What we need is to have some general mechanisms and some general infrastructure for that. Now, the W3C is working on that. So I would argue that first of all, you need to get involved in the W3C activity, because if there becomes a W3C sort of standard, then industry begins to take some notice of it.
I'm sorry, why should the private sector listen to the W3C? I mean, what is their governance? I mean,
Sorry? Why should
I mean, there's a lot of debate, certainly not.
Well, yeah, but I mean, yes, there is. And what good has W3C's open standards done in the past? Let's think XML, HTTP, HTML. I think that XML, I mean, that's the reason. I mean, they can gainsay it and say, no, we want to kind of push our own proprietary standards. But I mean,
would you claim HTML7 as well?
Well, yeah, I think, keeping things in some sense in a discourse which is more open, which allows people, I mean, this is not public sector over here, private sector over here. I think, I would just say as well, I think there is a real recognition that the provenance issue is key. Within the UK open data community, They're doing a lot of work on a provenance characterisation, partly based on W3C, but also Shotton's work in Oxford is people working in those areas on biological provenance is informing that. So it's essential. I don't think the council, I mean, I think they are problems. I mean, on Carol's slide there certainly are, but some of those infrastructural elements are starting to appear. So sameas.org, it's not a perfect service, but it's a service where you can assert equivalence or you can assert or attest an identity or an equivalence between one URI and another. That doesn't mean it's guaranteed. It's not a logical kind of closure over this thing, but of course what you hope with this is that the long tail of utility, the Darwinian process of selecting out the good URIs driving out bad, or good links driving out bad, is kind of the principles we're after here, I think. And as you get more of a critical mass, hopefully you'll start to see that people's conform both to some standard services like backlink services, equivalent services, essential provenance annotation, where that starts to emerge. We haven't got all the answers.
But there's also the issue to do with if, okay, so you've got same as and you've got a same as service. Well, who is the governance authority that does that? Because the same as service for, the pharmacy industry, in pharmaceutical industry, is different to the one for local government. So we need to also not just provide the tools and the framework, that's the technical approach, that's the technical determinism approach, but it's also the cultural approach of a particular community has to create an authority in order to be able to manage this. And this is what I was trying to get to, is that we need identity and ontology authorities, and they will be discipline or domain specific, and they really should be part of well-established organisations in order to be able to really penetrate. Now, in some businesses, like the biotech, there are well-established organisations, Bestower Alliance, for example. But others, it's less clear. And particularly, I'm not quite clear where they are in government. I presume that there are organisations, but
well, I think some of that will have to get invented and established. I think that's an interesting question. Some of them are there. I mean, certainly this, in general, what governments do well is actually maybe. They do collect data to quite high data levels, and they go through a process. The Office of National Statistics has a huge amount of effort given over to the proper audit and the proper set of accountable procedures, which in some sense don't just let statistical missamples out there. I mean, you can argue about whether they've got it right or wrong, but they exist partly to stop the politicians meddling in data when it's too raw. You can argue about where you put the balance point in that, but I think the idea that authorities will need to come into existence, which are the arbiters or are places you go because you trust that they're issuing stable, their version control is sensible, that is a whole piece of infrastructure that will gradually, if there is any momentum and any real utility in this approach, because we can imagine what it would be like all we like, but it is undoubtedly the case that unless there is an overwhelming requirement for this, we can't just legislate it so. I mean, there really will have to be, people like Google are starting to notice RDFA because it's there, increasing amounts of it.
But you're very lucky. I'm sorry, just one last
I'm
thing.
sorry.
I think you're very lucky. You and Surreal, very lucky that you have the sanction that you do. But the questions you're posing have a transnational significance to them. I mean, we are talking about the new architecture for data, and that affects everyone, not even in English, but everyone.
yeah,
And with the kind of authority and the kind of trust that you're talking about, that's a huge, huge issue.
Yep.
Where is that? What is authority? How is authority sanctioned?
Exactly, and I think well, we have the big vision, but we have to take small steps. So we have to keep that big vision, but we have to partition it into smaller steps within communities. Because if we try to think there should be a universal mechanism for governance, we'll be just screwed. Nothing will happen. So instead, I think we have to follow the well-managed islands approach for data of high value that has immediate return in doing the data in this way. And then build up from that, because we have to also gain the experience. So I see that that's the approach. Of course, then the danger is that we end up with silos of authorities. So we just, this is the conservation of complexity. You simplify it somewhere, you move the complexity somewhere else. So, but I don't see any alternative, and I'd be interested to hear if other people have alternatives.
Thank you. I think, a lot of this is incredibly emergent. Just like with the web, you see a lot of these things starting. Another thing that I wanted to throw out there, which changes the whole view of semantic web, is the mention that Google is taking interest, Facebook is taking a huge interest. They are about to or have started to dump billions of triples out there on on the open web. And so it'll be very interesting to see who comes up with provenance and trust issues when it comes to things like personal data. A lot of the guardians who are putting themselves forward with people like Facebook. The idea of Facebook and trust and authority on privacy is something which is quite an interesting thing to put together in one sentence, I think. But I have different views. If we can have another question. Yes.
I'm Steve Rawling, I work for the BBC in Manchester. A lot of new technologies and new applications of existing technology seem to have a breakthrough moment where they go from minority interest to mainstream awareness. And the most recent one you can think of is Twitter during the Iranian elections. Do you think that the census next year could be the breakthrough moment for open data? And if so, what could it look like? And what could it be like from the big audience's point of view? And is the infrastructure there to make the most of it? I'm very interested in what you said about OS maps becoming available, because that's been very hard to get, and it's absolutely brilliant. And you're right, it's a national treasure.
Yeah. I mean, it's a matter of public record that Tim and I didn't believe we would have the time or wherewithal or backing to get geographic data. It was put in the too hard box when we started the project. It turns out, though, that it's such an essential part of national infrastructure that, as I say, you can't make sense of all the rest of it. Place and space, locality is what people very often care about in contextualizing information. And it was essentially a national weirdness that we were having to pay for our postcodes and to know about information that established where our legal rights and entitlements were in terms of geography. So, but I mean, but I have to say, I mean, just moving straight on from the geographic administrative boundary content, one of the national scandals is that we do not have a definitive publicly available address database. Okay. In fact, we will be putting one together for the purposes of the census from the Post Office address file, from Royal Mail, from various parts of Ordnance Survey, and the bits will be backfilled, about 20% will be backfilled under a separate contract, and after the census it will be thrown away. Because there is legislation in place that information constructed under certain kind of conditions, particularly for the census, is under the Census Act, which is very, very draconian in terms of how data and when data can be. So it would be a breakthrough moment, potentially, if we could get hold of the bloody stuff. And I think there is an issue there to argue about, but I mean, the libertarians on the one hand will say, you know, that could be a moment. Other people say, actually, there are really good reasons why there needs to be time to reflect, to process, to aggregate, to compartmentalize and organize information sensibly. So we are not, I should say, even though those of us who are pushing hard for open government data, arguing that it should all be immediately available at point source, because there are serious issues about sampling, distribution. But where you've got bits of the architecture which are really important for putting the rest together, it would seem, I think maps are a bit of a breakthrough moment. I think postcodes are a bit of a breakthrough moment. I think there are key data sets like that where people can start to see that it matters to them, it makes a difference to them, where their NHS dentists are, you know, where the bus stops are is the latest one that I think we're very pleased with, you know. What about rail timetables? You know, we can come up with a list of other things that we'd like to have. Whether there'll be a breakthrough moment, I'm not so sure. I mean, maybe it will be just steady aggregation. But at some point, people will recognize that they've got a capability to analyze and interact that wasn't there before. In a way, you think it might be the census. It's a big blue ribbon project. It's hugely admired. It's hugely resourced. I'd be interested in other people's views on census data, whether that's an opportunity or a challenge.
I think we've had a lot of discussion about very similar questions about what is the sort of killer app of the semantic web. And despite the fact that I hate the question because it puts into the context of this whole movement something that needs a very specific identifier. So what is the killer app? What proves the semantic web works? It's kind of asking the same questions. What's a killer app for the web? It's a difficult one. To some people it's Facebook, to some people it's Twitter, to some people it's HTTP REST. And I find it a strange question to ask, not to criticize, but the whole idea of Twitter, which is a very public-facing thing, you know, the idea of something. So Twitter works on the web, so it's kind of hard to correlate something which is very public and public-facing with it. But having said that, with things like the postcode paper, which I don't know if you've seen, but it was put together as on a hack day where some people who possibly in this room were there to put it together. It's essentially taking whole bunches of open data sets, some of which weren't open actually at the time, including the well, I just got a photo of it here. I had one in my bag until last week, which was quite annoying. Taking together things which are public, putting them together in a way that's very consumable. So I think there are these examples of sort of proof of concept projects which are emerging. We're very, very, very early in this. Open data, I mean, data.gov.uk was launched in January. We've had a few months. And a lot of the data isn't there, or it's still being cleansed, or it's still being published. And we've had the postcode data set, sorry, the geographic data set for, you know, a month. So, and another question, please. Yep. Right at the back.
Tim Davies, currently studying at Oxford Internet Institute, and it sort of follows on from that, and I think a number of speakers talked about the end users of the data, and that we've built some of the tools for publishing data. We've still got that gap, and I'm just interested in the panelist's view. If we take the non-technical user who's not going to look at their Sparkle, maybe even the CSV file they're struggling to sort of work out how to operate with, what's the missing tool set and parts of the tool chain for those people, and are we close to building any of that, or is that still a long way off?
I think it's very different for different people and for different groups. Ultimately, you want a client that is similar to the browser user agent. Ultimately, you want that to be able to grow. But it's taken the browser 20 years to get where it is now, from NCSA Mosaic to something that's got HTML5 and data grids built in and JavaScript built in and everybody arguing about efficiency and optimization. It's probably going to take a similar time or longer before you get the semantic web equivalents. I was going to make another point there. Let's see if I can remember what it was. I'll pass on to somebody else at this point and yell back.
Actually, it is a good point, particularly the kind of complexities of Sparkle endpoints and RDF astronauts, as they're variously referred to, kind of promoting these exotic formalisms. I mean, some people out who consume this stuff will just want, you know, a straightforward JSON or Python script. There are developers out there who are good developers who find this world pretty exotic. One thing that is happening is that the UK, data.gov.uk, will be rolling out an API for a common RESTful presentation of a really simple way of accessing these data sets, really simple. So I think that's pretty important, that you take some of the mystery out of this at the really quite low level, because it can look a little bit miraculous.
The other point is that for your typical end user, my mum wouldn't know a chunk of JSON if she tripped over it in the street. What she would know is that there was this mysterious client that one of her sons could download and put on her machine that did something useful for her. Now, a lot of the tools that are already being developed around web services end up being delivered through a browser, but they are quite complex tools that have done quite a lot of conversion and calculation in the background.
and they're actually coded using Flash or big chunks of Ajax or whatever. So what's it going to be delivered in for the end user? Probably it's a browser application or something that they end up downloading. And to go back to the point of killer apps, the killer app of the semantic web is that you can take the data from all over the place, you can aggregate that, and you can present it to individuals. Was anybody at the Fab Lab opening, or has anybody used the Fab Lab that's in Manchester? The original background to the Fab Lab was how to make almost anything. And the professor who ran that was inundated with requests from people like art students wanting to make something that was personal for themselves, with all of the mysterious tools and so on that were available at the time. I think the semantic web ends up being the ultimate personalisation tool for content, where you can tailor it and the data feeds to what you want and what you want to do. And that ability to get agents that retrieve data and do what you want with it, ultimately, I think is the killer app. But it's a different killer app for everybody.
So I don't think there'll be, we'll have the Sparkle endpoint thing. It will be the tool of the real plumber, the real engineer. Instead, we'll have a proliferation of very simple APIs that do one simple thing really well, that happens to transport information in an RDF form that happens to use a small amount of control vocabulary for that specific task. And then we'll have tools that allow you to combine all of that. So I think that proliferation has got to happen. And we see it in things like open social for social websites. We'll see there's an ontology called Shock, incredibly small ontology for semantically interlinked online communities. And those are the kinds of things. There's an ontology called Void, which allows you to say, this is a data set, and this is where it came from. That's about it. But that's enough for you to get some basic information about some provenance. And so I think we'll see a lot of proliferation of very small, simple things to create Lego pieces that will then, and then we can build large-scale Lego. I think, you know, the Sparkle thing is kind of revealing too much of the pipe work.
Yeah, I absolutely agree. In the same way that we don't interact with the web by typing in PHP to get the information that we want, we use something like Drupal. Even, you know, there's layers and layers and layers and layers, and one of the things to remember is that the semantic web is part of the web. It's not a sort of next generation change. We're all going to get rid of Web 2.0 and move into Web 3.0. Oh God, I hate those phrases, but you know, it's not as simple as that. In the same way that the Web 2.0, if you want to call it that, moved from existing things into communities and blogs and all this stuff. It's emergent, it's slow, and it's innovative. You have to have innovation happening all over the place for these kind of things to happen. So we're running out of time. I'd like to give a very quick thank you to my panelists, Nigel Shadbolt, Carol Goebel, and Peter Crowther.